This video is part 1 of 2 about the HalfBall Hit at pool. What is so special about the HalfBall Hit that it deserves this level of attention? Is it that it is the hit or the overlap that neatly cuts the cue ball in half like this, or the hit or the overlap that neatly cuts the object ball in half like this? Or is there something more to the HalfBall Hit than merely being the 50-yard line or the continental divide between thick and thin for cut shots at pool? Well, there is more to the HalfBall Hit than this, quite a bit more. But there's nothing really new in this video. Much of this has been known for an awful long time and can be found in Burns's books, some of it in Amateur Physics for the Amateur Pool Player by Ron Shepard, and virtually everything I talk about here is in an excellent series of articles written by Bob Jewett of the San Francisco Billiard Academy. Some people think the cut angle for a HalfBall Hit is 45 degrees, but it isn't. Neglecting object ball throw, it's 30 degrees. So what I'm going to describe here is 4 pieces of information that I'll call gems about the HalfBall Hit that I think are useful to know and I think are helpful to your game. I'll describe the first 2 in part 1 and the second 2 in part 2 of this video. And I'm going to leave for last the one that I think is actually most important and least appreciated of the 4. So the first gem is that the HalfBall Hit is the only cut shot with a clear aim point. Think about this for a minute. To aim a HalfBall Hit, you look directly over top of the cue ball, over top of the stick, and you aim perfectly for the edge of the object ball. And every time you aim for the edge of the object ball like this, the object ball goes off at the exact same angle. And that angle, which I called 30 degrees just a minute ago, is actually a little bit less than that because of friction between the cue ball and the object ball. It's about 28 degrees. You should remember this angle. You should learn to recognize this angle. When I say remember this angle, I don't mean think about trigonometry or remember numbers or anything like that. I mean learn to recognize what this angle looks like on a pool table. There's other places in your life where you recognize angles, whether you know it or not. Here's an example of a staircase. A typical staircase has a rise of 6.5 or 7 inches on each step and a run of 10.5 or 11 inches on each step. So this makes an angle of about 33, give or take a few degrees from the horizontal. And you recognize this angle. You've seen it so many times. If you walked into somebody's house and they had a staircase that went up at 40 degrees from the horizontal, it would look wrong to you. It would look steep because you have this angle ingrained into your head. You need to learn about the HalfBall Hit angle in a similar way. So let me show you several examples of HalfBall hits. Here's a HalfBall Hit down into the corner pocket, a HalfBall Hit into the side pocket, a HalfBall Hit up past the side pocket into the corner, down the short rail, a HalfBall spot shot, a HalfBall Hit back cut into the corner pocket, a back cut from the foot rail into the corner pocket. Here's that must-make straight pool shot that you get at the end of a safety battle. And finally, here's that HalfBall Hit 9-ball shot on the 9-ball that your opponent just won't quite concede. You need to recognize these shots. You need to recognize these angles when you see them on the pool table. And so here is a drill to help you learn to recognize the HalfBall Hit angle. Place a marker like a paper hole reinforcer at a random position on the table and put the object ball on top of it. Then position the cue ball approximately as shown for about a HalfBall Hit into a particular pocket. Put a coin right behind the cue ball, at the base of the cue ball. Then execute a HalfBall shot, and if the object ball misses the pocket, move the cue ball sideways in the appropriate direction, repositioning the coin, and repeat this until the HalfBall Hit splits the pocket. Once you get this, put the cue ball back in position and put the coin there, and walk around the table looking at the HalfBall shot, telling yourself this is the HalfBall angle, and then go through your pre-shot routine once again and hit in the ball one more time. Repeat this if you did a cut to the right into the pocket, repeat this for a cut to the left into the pocket, and then repeat the whole procedure for different pockets. The value of this, what this allows you to do, is not only to recognize a HalfBall shot when you see it on the pool table, but to recognize when you have a shot that is a little bit thicker or a little bit thinner than a HalfBall shot. And then whatever mechanism you use to aim the shot, when you get down into position, you should know my overlap should be a little bit thicker than a HalfBall overlap or a little bit thinner than a HalfBall overlap. It's a double check on whatever technique you use to aim. So that's the object ball. What about the cue ball? There's a much bigger variety to the path that the cue ball can take in a HalfBall Hit. depending upon whether it has forward spin or no spin or back spin when it strikes the object ball. If the cue ball slides into the object ball as in a stun shot, then as usual, the cue ball goes off along the tangent direction perpendicular to the direction of the object ball like this. But the stun situation is neither the most common, nor the most important, nor the most interesting situation for a half-ball hit. The more common, important, and interesting situation is when a cue ball rolls into the object ball, when a cue ball has natural roll in a half-ball hit. A natural rolling cue ball has a spin that is commensurate with its speed, so a faster rolling cue ball has more spin than a slower rolling cue ball. But any of these rolling cue balls, when they strike the object ball in a half-ball hit, a bunch of the speed in the immediate aftermath of the collision, the forward speed is taken away, but the spin is not taken away, so the cue ball is spinning in place. It's burning rubber as it's starting to go off along the tangent line, and that causes it to accelerate forward of the tangent line until it achieves natural roll again, and then it goes in a new direction that, for the case of a half-ball hit, is about 33 degrees from the direction of the straight. If the cue ball was rolling fast into the object ball, then it might take a path like the white arrow shown here. If the cue ball is rolling a little bit more slowly or the cloth is a little bit stickier, it might take this path or even this path for a slow rolling cue ball. So this is the situation we'll focus on quite a bit in part 2 of this presentation, the case of a slow rolling cue ball and a half ball hit. But in any case, all of the skidding on the cloth, all of the burning rubber occurs pretty much in this little yellowed circle area. So in the case of a sliding cue ball, the cue ball takes the green tangent direction. In the case of a naturally rolling cue ball with topspin, the cue ball goes off in this forward direction, the solid white arrow here. What about for a cue ball with backspin? What about a person who draws the cue ball? What are the possible directions for the cue ball here? Well, it turns out that the maximum backspin that most humans with a good stroke can get is about the equivalent of natural roll, but in the other direction. We call that reverse natural roll. So the cue ball with maximum backspin will go about the same angle before the tangent direction as the follow case puts you past the tangent direction. This leads us to the second gem about the half-ball hit, and that is that a cue ball with maximum draw will go pretty much exactly sideways. This is useful to know. A cue ball with reverse natural roll will go pretty much perpendicular to the direction that the cue ball was struck after it's achieved natural roll. And this is useful to know because sometimes you need to know whether it's possible to draw a cue ball in a direction that goes backwards of this angle. And you look at the overlap, and if the cut is thinner than a half-ball hit, then you're not going to be able to do that. So in summary for part 1, the half-ball hit is the only cut shot at pool with a clear aim point, and maximum draw with a half-ball hit sends the cue ball sideways, perpendicular to the direction of the stick. Part 2 will introduce gems 3 and 4, and both of those refer to naturally rolling cue ball with the carom angle of 33 degrees that I discussed earlier. Gem 3 will actually focus on an issue that involves the path of both the cue ball and the object ball, and Gem 4 will introduce some interesting things about that 33-degree carom angle for the half-ball shot.